Hi students, my name is Alina Athar and today's lecture is all about acid-base theories. So it's a very important one and my objective here is to explain the evolution of acid-base concepts and their applications in chemical processes. So let's begin with a fundamental question: what is an acid? Traditionally, we all learned that acids are sour, bases are bitter, and when acids react with bases, they form salts. But in chemistry, these definitions have evolved over time to adapt to various systems from aqueous solutions to industrial applications. So let's discuss about the three major acid-base theories. Starting with the Arrhenius theory, which came in the year 1884. Let's say what this theory says. So it defines acids as substances that release H plus ions in water and bases as substances that releases OH minus ions in water. So let's take an example. Okay, we have HCl. HCl releases H plus ion in water, like H plus Cl minus. So yeah, that's an example of an acid. Then we have base, which is NaOH, sodium hydroxide, which releases hydroxide ion in water, OH minus, Na plus and OH minus ion. But there is a limitation to this theory. The limitation is it only applies to aqueous solutions. So then came another theory, which is called Bronsted-Lowry theory, in the year 1923. Now what this theory says, it defines acids as proton donors and bases as proton acceptors. So let's take an example. Here we are taking ammonia and water. Now what will happen when we react these two together? So here ammonia acts as a base, that it will accept one proton and it will become ammonium ion, NH4 plus, and water will donate its proton, so it will act as an acid here. So what is the application of Bronsted-Lowry theory here? It explains the concept of acid and bases in non-aqueous solutions such as ammonia and organic solvents. Basically, the limitation that we can see in the Arrhenius concept, this theory will help with that. Okay, now let's come towards the third theory, which is again a major one. We called it Lewis theory and it came in the year 1923. It defines acids as electron pair acceptor and bases as electron pair donor. Let's take an example here also. Boron trifluoride, when it will react with ammonia, here BF3, it will act as a Lewis acid and ammonia will act as a Lewis base. So yeah, basically BF3 will accept an electron pair and NH3 will donate the electron pair. Okay, now what's the application of this theory? Here this theory, it is used widely in catalysis and complex formation. So with this we have done with all the three major theories of acids and bases. Okay, so let's talk about industrial applications. Here we can talk about petroleum refining, acidic and basic catalyst. For example, H2SO4, sulfuric acid, it is used in alkylation processes. Then we talk about pharmaceuticals. Here acid-base extractions are used to purify drugs. And like there are a lot of industrial applications. Now what is the need of studying acid base, what is the environmental relevance of it? So we all know about acid rain. What is an acid rain? Acid rain basically is the result of sulfur dioxides and oxides of nitrogen, and it's super harmful. Like it forms acid in the atmosphere and it has so many disadvantages. So understanding the concept of acid base, understanding the neutralization of acids and bases will help mitigate its effects. Then we also have modern relevance of studying about acids and bases. Talking about modern research, here we can study about proton transfer reactions in fuel cells. Now let's just end the topic. Okay, so I have a quick activity idea. So imagine we are designing a neutralization reaction in the lab. Suppose we add sodium hydroxide to HCl. Now what happened? Think about the ions involved, write the reaction and calculate the pH of the resulting solution. So yeah, that's your homework, and thank you for watching the whole lecture. I hope this helps a lot.